Hello everyone, this is Dr. Fan. Pulley system is a very popular type of question in AP Physics. Many students find the Pulley system question are very hard. The reason for this is because the student do not understand the essence of Pulley system. So, what is the essence of Pulley system? Let's work on it today. Alright, so for most of the Pulley system in AP Physics, the Pulley system is a simple pulley. So what does it mean? First, for simple pulley system, the pulley itself is frictionless and weightless. That means you don't need to worry about the rotation of the pulley, and you don't need to worry about the friction between the pulley and the string. That's the first important thing about a simple pulley. The second thing is the string itself is non-stretchable. What does it mean? That means the acceleration, the velocity, and the displacement on both sides of pulley are the same. Okay? Why this is the case? Just imagine what if the acceleration, velocity, and displacement are not the same. Let's imagine big M is faster than small m. Big M is faster than small m. What will happen? The string will break because big M moves faster than small m. What if big M is moving slower than small m? That means the string will be slack, so there will be no tension at all. So because the string is not stretchable, so the acceleration, velocity, and displacement are always the same. Alright, now if we understand this, pulley system should be easy for us. Let's consider this specific pulley system. If we assume big M is heavier than small m, then we know big M is going to go down and small m is going to go up, right? So if that's the case, meaning basically the whole system is moving clockwise, right? So for big M, we can do the free body diagram. So we have Fg going down, we have tension going up. Then we can write down the Newton's second law for big M. So for big M, the Newton's second law is sigma F net equals to mg minus Ft, which equals to big M times its acceleration. Let's call this equation 1. And for small m, we can do the same. We know the tension is going up and gravity is going down, right? So for small m, my net force is tension minus small mg equals to small m times acceleration, which is my equation 2. Remember, these two acceleration has to be the same. We have discussed right here, right? The other thing you need to pay attention is because big M is moving down, small m is moving up. So I want my positive direction for big M going down and my positive direction for small m going up, right? That's how we get these two equations. Now, if I add equation 1 and equation 2 together, what do I get? The tension would cancel out. I would get big mg minus small mg equals to big MA plus small ma. So if I rearrange this equation, I would get this. My acceleration equals to big M minus small m times g divided by big M plus small m. So let's call this equation 3. In other words, you see, I get my acceleration right away. So how do I get my tension? I can substitute this acceleration into any of the equation 1 or equation 2. I can get my tension. So I have done that. Let me just write down the answer here. So my tension would equals to 2 times big M small m divided by big M plus small m times g. Let's call it equation 4. So how do we interpret all these equations? If we look at equation 1 and equation 2, we know the big M is heavier, so it will move down. That means my tension would be smaller than my big mg. So that means my tension would be smaller than my big mg. And for small m, I know it's going to go up. That means the tension is larger than the weight of the small m. That means my tension is larger than small mg. So basically, you know the range of your tension right away. That's one thing you can know. And the other thing is, how do we interpret this acceleration? This is a very interesting equation because you can see that on the numerator, which is the difference of the two weights, right? It's big mg minus small mg, and then divided by big M plus small m. What if I consider my big M and small m and the string as my whole system? For this whole system, I only have two external forces along the string. One is gravity for big M, pulling the whole system going clockwise. The other is for small mg, pulling the system go counterclockwise. So the net force you can consider is big mg minus small mg. And the whole system includes big M and small m. So I get my acceleration right away. In other words, you can interpret this acceleration from the idea of the two-block system. If we have all this knowledge in our head, we should be able to solve the Pulley questions in AP Physics very easily. Let's look at some real AP questions right now. Okay, this is one real AP question. The question says, each of the diagram below represents two weights connected by a massless string which passes over a massless frictionless pulley. In which diagram will the magnitude of the acceleration will be the greatest? We know for all these systems, the acceleration equals to big M minus small m times g divided by big M plus small m. So for A, the acceleration would be 2 minus 1 divided by 2 plus 1 times g. So the answer would be 1/3 g. And for the second choice, we're going to do the same thing. The acceleration equals to 4 minus 3 divided by 4 plus 3 times g. So it's 1/7g. And for the third choice, the acceleration is 8 minus 5 divided by 8 plus 5 times g. So we get 3/13 times g. And for the fourth option, the acceleration we get is 10 minus 6 divided by 10 plus 6 times g, which is 1/4g. So if we compare all this acceleration, clearly A has the largest acceleration. So we get the answer right away. Very straightforward, right? We finished this question in less than 1 minute. Let's look at another question. So this question says, a simple Atwood machine is shown in the diagram above. It is composed of a frictionless lightweight pulley with two cubes connected by a light string. If cube A has a mass of 4 kg and cube B has a mass of 6 kg, the system would move such cube B accelerates downwards, which makes sense because B is heavier and A is lighter, right? So they ask what would be the tension in the two parts of the string between the pulley and the cube. If you remember what we discussed before, you know the tension equals to 2 times big M times small m divided by big M plus small m and then times g, right? You can plug the mass of each block, then you get the tension. But in this question, you actually do not need to do that. Why? Let's look at the choices. So the choice A says the tension on the left side is 47 Newton and the tension on the right side is 71. This is clearly wrong because we know along the same string the tension would be the same. So option A is wrong. If we look at option C, there's the same issue. The tension on both sides of the string would be the same. So this one is wrong. And then we only have two choices, right? Option B says both of the tension should be 47 Newton. Option D says both of the tension should be 39 Newton. Because we know the tension should be larger than the weight of the small mg and smaller than big mg. And for small mg, its weight is 40 Newton, and for the big mg, the weight is 60 Newton. So that means my tension needs to be larger than 40, smaller than 60. So option D is also wrong. So B is the only choice, right? So we basically utilized this relationship in simple pulley system, which is the tension is between the weight of the lighter one and the heavier one. Very straightforward. All right, let's look at another question. So this question says, a simple Atwood system remains motionless when equal mass of M are placed on each end of the cord, which makes sense because if you have M on this side, M on this side, it should be under equilibrium, so there should be no motion. But when a small mass is added to one side, the masses have an acceleration of A. What is big M? You may neglect friction at the mass of the cord and the pulley. So for this question, we know the right side is heavier. The total mass on the right side is big M plus small m. And we know the left side is lighter. The total mass is big M. If we consider all the blocks and the string as my system, I know gravity on the right side is pulling the block to move clockwise, and gravity on the left side is pulling the whole system to go counterclockwise. So for the whole system, I can write my net force for the whole system equals to big M plus small m g minus the force on the left, which is mg. So my net force is basically small m times g, and which equals to the whole system's mass times acceleration. So for the whole system, I have big M and small m and another big M on the left side, and that times the acceleration is my net force. So if I simplify this, what do I get? So basically mg equals to 2 times big M plus small m times A, right? So then small mg divided by A equals to 2m plus small m. So mg divided by A minus small m equals to 2m. Then I can find my big M. So if you look at all the choices, A would give you the correct answer. So we solved this question very easily. Alright. So as you can see that as long as you understand the essence of pulley system, all these questions in AP Physics about pulley are very easy for you. So what is the essence of simple pulley system? First, displacement, velocity, acceleration on both sides are the same. This is very important. The second thing we know is the tension is between the weight of the lighter object and the heavier object. The third thing we know is if you want to find acceleration, you just need to consider the whole system. You don't need to look at the individual system. If the exact value of tension is needed, then you can construct the free body diagram of either block. Then you can find the tension. Alright, hopefully today's discussion is going to help you to solve pulley systems very efficiently, and I'm going to see you next time. Thank you.